Hello again, Bill Boggs here. Back in the holidays, I did an unboxing video of this machine. This is the Highland Park HP-8 8-inch Intarsia machine. I've used it for getting close to a year now, personally in myself and also in a number of classes at the William Holland School where I teach Intarsia classes. I really like the machine. It's got a lot of really great points. It's built like a tank. It is heavy like a tank, but being that it's a Highland Park machine, I know I'm going to get plenty of years of use out of it. So the purpose of this video is to cover some more details. For example, we're going to talk about the water delivery system, the water removal of the drainage, how to change the laps, various adjustments throughout, the attachments, and cleanup. And I'll probably hit on some other things in between, but those are the main points. So let's get to it. All right, a good place to start will be the water delivery system, beginning with the bottle of reservoir up here, the quick disconnect fitting here, push to connect, plastic tube, the valve here, which you adjust to get a slow drip down through the copper tube and ultimately onto the lap. Early on we found out the hard way that there's no pressure relief valve up here. So what was happening was the bottle was pulling a vacuum inside here, and it was like the old term vapor lock. And in order to resolve that, HP came up with this solution to just puncture a little hole in the top of the jug here. That resolves that problem. And then next we got the quick disconnect fitting, the push to connect. I've had some questions about how to use this fitting on the top of the water bottle, and it's a standard product that you can get most hardware stores or Home Depot. The way this works is you take the tube and you actually push, got to put some pressure on it till it bottoms out, and then it's in there. It's in there good. It's watertight. It won't come loose. And when you get ready to refill the water bottle and you need to take this off, pull down on this fitting slightly. I'm doing it with 2 fingers. See, it goes down. And as soon as you pull down, it will release the tube and it comes out. So when the jug runs out of water, the procedure you follow is, since you've got a hole in the top, you need to put your finger over the hole, and then you can turn it upside down like this, unscrew the top, and then go fill up this jug. And I'm still holding that, because if I let go of that, see, it's going to drip out. Top it off with water, come back, screw this on, and then load it back up here. Now that works okay. You don't have to do it too often, but it is kind of cumbersome. So a couple people came up with some solutions to it. The first person that I saw do this was our friend Martha Graziano. And what they did was, instead of having a pinhole up here, they drilled a little larger hole, probably about 1/2 inch in diameter, and they put a little funnel in it. Next, we'll adjust this needle valve up on top. We want just a little bit of water dripping through. We don't want a stream of water. You want just enough. With the proper flow rate, let's see. Now, even though you probably can't actually see the water flowing down, it is indeed flowing. There's enough surface tension there to pull that water across to the lap without destroying the tip of the copper tube on there. So with this going, and that's more than enough water to distribute clear across the lap. And if necessary, you can always adjust for more flow rate, but it's not necessary. So we've talked about the water delivery system. Now what about the water removal, or the drain? Here's the shot of the back of the Intarsia machine. And that's the hose fitting to connect the drain hose. When I got my machine, it had a good hose like this, reinforced plastic. What I found though was it was not long enough for my purposes. Since I moved my machine a lot, consequently I ended up having my drain in the front. So I needed to run the hose around to the front of the machine and then down to the drain bucket. And the hose that came with it was not sufficiently long. So I went down to Home Depot and I picked up some additional hose, and I'll show you a picture of the part number if you run into that same problem. If you're going to have your machine sitting on your workbench and not moving around a lot, then you probably won't run into that issue, and you can run the drain to the back of the machine and perhaps down behind your workbench. But me, I have to move my machine a lot, so I just needed to be able to have the flexibility of letting it drain in the front. One of the things that I really love about this machine is this light and its adjustability. For me, it's particularly helpful if I'm doing a really fine line. I can get down right on top of it and see it, whereas with the fixed light of the old machines, that was always a problem. Now you notice on the tray, it's got this debris that's caught up here. And as you continue grinding, this puddle of stuff gets bigger and bigger. And if you're grinding something that's, particularly if it's real soft, it builds up, and pretty soon you find out it's running out here. So a practice that I've been doing for a long time is I keep a squirt bottle handy, and I use that. I just keep it cleaned off. And that way I know I got a perfectly flat surface on this shelf, and it's nice and clean. And being clean, I'm able to see it better. In particular, again, when I'm doing fine lines for borders, it's real important that you have plenty of light to be able to see that and have a nice clean tray. Conceivably, you could have such a buildup of material here that it would force this not to be perpendicular. It would raise this up enough to affect what you're doing. Okay, eventually the lap's going to wear out and you're going to want to change it. So there's a couple of steps that you'll have to take before you get to the point where you can actually change the lap. The Allen screw on here is a 3/16 size, but the problem is if you try to do it as the machine is together like this, assembled, and you run into problems with the copper tubing, you run into problems with this cowling on it. So the best thing to do is just to remove this temporarily. And we do that with a Phillips head screwdriver. There are these two small stainless steel screws. Small, I say small, they're short. Don't lose those. Now we'll flip this around and do the other side. Now with the 4 screws removed, then it's an easy step to carefully lift up on this cowling, and careful not to bend the copper tube and mess up the alignment on that. And set that aside, and then you have access to the lap. And to remove the lap, this is a 3/16 Allen screw, so 3/16 wrench. Loosen it up. And you have a retaining piece here and the screw, and then you can just pull this off. Now, let's talk about laps briefly. The laps that was sent with my machine, and I think most of the early machines, was an 80 grit lap, which is much too aggressive for anything that we'll be doing. Over the years, I have settled in on using a 180 grit. That seems to be like an optimum for me personally. I teach a lot of classes and have been through a lot of different students, and I've found that the 180 is a good compromise. It accomplishes everything that you need to do, and probably use this 95% at least of the time. If I'm doing something problematic like Charoite or Larimar, or perhaps some mother of pearl, things that will tend to chip off, I'll drop down to a 260 lap. But other than that, I use the 180 exclusively. The other thing about laps is I have always been a proponent of using the adhesive laps, the PSA pressure sense adhesive laps. They served us well on the old machines, but I think that I'm slowly coming over to just using the topper lap without the adhesive. They're a little bit less expensive, but the only thing you have to be careful of, make sure that you order from a reliable source so that you get laps that are nice and flat. If you have the slightest warp in your lap, it won't lay flat on the master lap, and that'll make it difficult to do things like particularly fine lines. So if we were changing laps, I would take this off, take a new one, lay it on there, set it back on, and then reverse the process. Now that we have the top cowling off of the machine, let's go ahead and take a look at the remainder of the drainage system. This is the bottom, and the hole down there in the bottom, that's where the water will drain out into the hose fitting and into the drain hose. Now, one of the things that I've noticed is if you use this very much, you're going to have a buildup of sludge in here. This is a flat surface on the bottom, and the sludge collects on there, and ultimately it clogs up, and you may have to take the top off, take the cowling off, and wash it out with a spray bottle. Keep an eye on that, clean the bottom of the collection area there. The other thing that will cause insufficient drainage is if your hose is not arranged so that you have a good gravity flow, a good downward slope into the drain bucket. And I've run into that a number of times, I guess because the hose I'm using is snaking around towards the front of the machine. So without the proper slope, it will fill up with water, and it will ultimately reach the bottom of the lap, and then it will fling the water at you. Let's talk about the shelf here on the front. Now, it's calibrated at the factory so that it's a perfect 90-degree angle between the lap and the shelf. You can verify that with a right angle. There's a couple of ones that any of those will work. So you would take your right angle fixture and set it up on the shelf and against the lap. It should be 90 degrees, in other words, perpendicular to the shelf. It's set up at the factory like that, but if some reason the measurement is off, so that you go to measure it and say it's like that or like that, then you can make slight adjustments to the shelf. And you do that with a 5/64 Allen wrench. First of all, loosen these screws here, and those are loosened with a 5/32 Allen screw. Just loosen it so that the shelf can rotate. And then over on the other side, see if I can zero in on that. Right down in these two holes here are Allen screws, and those are used to adjust the slight tilt of this shelf. This is a 5/64 Allen screw. I'll go ahead and adjust it so that it's out of whack here. All right, so I've adjusted one of the screws. You can see it moves a little bit. And when I put the jig up against it, you'll notice I've got a gap right in here. So what we'll need to do is adjust this tilt so that it's perfectly 90 degrees. And then we'll tighten up this Allen screw. And if the adjustment needs to be done in the opposite direction, you'll do that with this screw. And you may end up having to do a combination of both till you get it set in. But when you're all set and done, these things need to be tightened down nice and snug so that there's no rotation at all on this shelf, and it's still sitting at 90 degrees. So the next thing we'll talk about on this is the removal of the shelf. You may need to remove it to clean it. Perhaps you need to get inside to clean things out. I have occasionally dropped pieces down in here that I was grinding. They've fallen down in the crack. So I've had to either take the cowling off or take the shelf off in order to get to it. But to remove this shelf, you'll take this 5/32 Allen and you'll loosen it. As soon as you get it loosened a little bit, you'll be able to turn it with your fingers. This is a knurled nut. It's about the only thing on this machine that's not made out of stainless steel, so you'll notice it's got a little bit of rust on it. I keep WD-40 on that. So then we'll remove this one. All right, and then gently move this. It fits in there very snug. You just lift up and twist it, and it'll eventually come out. Now it's heavy, it's solid stainless steel. The way it's held in place is with these two screws, which give it a rotational ability, but then there's this little shelf here, this little lip that sticks out, and this is the bottom of those two Allen screws that I was adjusting, and they sit right on top of this little shelf here. This little shelf here I found does get dirty as you're grinding stuff, so just clean that off. And then you have access to the inside of the cowling here. Now to put it back on, just reverse the procedure. Make sure that you've got these two screws on this end. Make sure you clean it off real well first. And then set it down in there, work it down. And then work this in there until you can twist that with your finger. Get it started. And again, I'd recommend putting some WD-40 on that. You have to wiggle the shelf in there till it's almost touching the lap. And you have to kind of feel your way in with these nuts till they begin to grab hold of the threads on the inside of the shelf. Kind of wiggle waggle it a little bit. All right. And then you finish tightening it up with the Allen wrench. And before you secure it up completely, you'd want to go in with your 90-degree fixture and just double check and make sure that it was still perpendicular. The water bottle sits on top of this stalk, and it does wiggle waggle around. So what you can do, at the bottom of this stalk here is a 1/8 inch Allen screw. You can take a 1/8 inch Allen wrench and just tighten that up, and then it won't go anywhere. So finally, the last thing we're going to talk about are these angle jigs. Now, I only purchased one of the jigs. That's the 45-degree vertical one. That's for doing mitering corners on boxes. And the way this works is it's got these two little pins that go into the matching holes on the table. And you just set that on the table. Now, it's very snug. Sometimes you have to actually go in and tap it down to get it to sit flat. Make sure that it is dead flat on there. And then there's these 1/4 inch flat flush mounted screws that go in here. And that will hold it steady. Now, we found out the hard way that even though this jig fits tight against the table, the shelf, once you start doing an angle on a piece, you're pushing in on it, and it will eventually, if it's not screwed down tight, it will actually tilt. And we found that out the hard way. So make sure that the flush mounted screws are screwed in snug, and that way it'll keep this perpendicular with the lap. So this is how you mount any of the jigs. To remove these, take the screws out. And on the side, there's a little slot right there. And you can put a flat screwdriver in there, in this case my knife, and just give it a little twist, and that will break the seal. And then you can just take it off. And that will work with any of the jigs they provide. I think that about wraps it up for what I intended to accomplish with this video. Mainly just on how to use it, how to take care of it without going into the details of making an Intarsia with it. I think if you've seen the other videos and made some yourself, it'll actually be self-explanatory. So this video covers the 8-inch machine, but the 6-inch machine that they make is basically identical except for just a smaller lap, a little bit smaller base on it. It's got the same half-horse motor on it. The drip system is the same. The hose for removing the used water is the same. The jigs, now, there's a separate set of jigs for that because the tray is smaller. So the 8-inch jigs will not work for the 6-inch machine and vice versa. But other than that, they're both great machines. I've used it, like I said, for about a year now, and I'm convinced it's much better than anything we had up there before, and it's going to last a long time. And finally, a little plug for the school that I teach in. If you want to learn to do Intarsia, of course, you can look at the videos and the book that I wrote. And if you have a machine or access to one, that will be really all you need to get started. But if you feel like you want to take a class, check into the William Holland School of Lapidary Arts. We're in Young Harris, Georgia, and the classes are 1 week. Priced very reasonably, and the costs that's listed covers room and board and tuition. The only additional expense is any material that you purchase, but I always encourage my students to bring their own material. It's always better to use your own stuff.